if we think about the quadratic formula, what part determines the solutions? Because there's different pieces. We've got negative b. Okay, well, that's negative b. And we've got this radical, and then you have the product of 2a. So what would determine the solutions? If you were to say the radical, you'd be half right. We have what's called a discriminant, and the discriminant is what's underneath the radical, b squared minus 4ac. This determines how many solutions you have because there's different types of radicals. You could take the square root of a negative, and is that possible? No, so then you'll have no solution. Okay, so make sure that when you're talking about the discriminant, it's not the square root of b squared minus 4ac, it's what's underneath the radical. And if you need to write on your notes, don't include the radical. Every year it happens, and every year I'm so sad because you're so wrong. Okay, so if we look at 4 different examples, the first one, if we were to use, again, just b squared minus 4ac, that would leave us with 7 squared minus 4 times negative 2 times 10. Okay, if we work that out, 7 squared is 49, negative 4 times negative 2 is 8, times 10 is 80, so we end up with 129. Interesting. Okay, well, if that's underneath the radical, can you take the square root of 129 without a calculator? No, you can't, because it's not a perfect square. So we still will have 2 solutions, but we'll have 2 real irrational solutions. 2 real irrational solutions. So if we were to graph that, what would that look like? Well, negative 2 is our a value. So it's going to open down, and it will cross the x-axis twice, because remember our solutions, and there they are, our solutions are x-intercepts, roots, zeros. Okay, take a look at the second example. So b is 7 again, so 7 squared minus 4 times a times c. Okay, so we get 49 minus 24, which leaves us with 25. So we still have 2 real solutions because you can take the square root of 25. Okay, so 2 solutions. But is 25 a perfect square? Why, yes. Yes, it is. So not only do we have 2 real solutions, but they're rational. Why? Because it is a perfect square. Okay, so far we've seen 2 different types of discriminants. One, where it is not a perfect square. So it only makes sense if you can't take the square root of a number that the solutions will be irrational. The second was a perfect square. And it makes sense that if you can take the square root of the discriminant, you'll have 2 real rational solutions. What's the square root of 25? 5. So I'm going to have negative b plus 5 and then negative b minus 5. On the second example, it looks like that because our a value is 1. It opens up and our x-intercepts are going to be right there. Okay. For this example, b is 8, so b squared, notice I'm not including the radical, it doesn't include the radical. B squared minus 4 times a times c, okay, b squared, 8 squared is 64, and then 4 times 2 is 8, times 8 is 6, oh, this is interesting, 0. Well, shoot, if I take the square root of 0, what do you get? You should get 0, right? So for our discriminant, it's 0. That means our quadratic formula is negative 8, because that's our b value. Okay, negative 8 plus and minus 0. What happened to the plus and minus if our discriminant is 0? It goes away. So we only have 1 solution, and you have 1 real rational solution. But how can I only have 1 solution? I'm waiting for it. Think about it. If I factor out the GCF, we get x squared plus 4x plus 4. What's on the inside? Ha 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 ha, a perfect square trinomial like we saw yesterday. Yes. So we call this a double root. You have two solutions. You always will. But it happens to be the same one. So for this, our quadratic still opens up because our a value is 2, but our vertex is on the x-axis. So we have one double root solution, okay? We still have two solutions, but we call it a double root because it's exactly the same. All right, the last type of discriminant that we will see, b squared minus 4 times a times c. We have 25 minus 4 times 3 is 12 times 4. Oh, what's happening here? We get a negative 23. Can you take the square root of a negative number? No, you can't, not under the real number system. So we have 0 real solutions, or I'm going to rewrite that because I need more space. More space. Okay. Come on. So we have 0 real, or we need to know that there are 2 imaginary solutions. And we'll talk about this next week as to what that looks like algebraically. But graphically, a is 3. And we did talk about this yesterday. So that means the vertex is above and it opens up. The solutions are imaginary. So 4 different types of solutions. When we solve for them, you guys know that that's just what we end up with. Yeah, but we now need to be able to determine the type of real solutions, okay, real solutions, without actually solving. And it's super nice because we just use the discriminant. So for example, number 3, it says, what's the number of real solutions? Well, there's 2 different, oh, pardon my throat. There are 2 different terms with a variable. So that means I'm going to have to set it equal to 0 before I can solve. And we don't actually want to solve. We just want to find the discriminant. So a is -1, b is 14, and c is -49. Our discriminant is b squared minus 4ac without the radical. So b squared is 14 squared minus 4 times a times c. And then if we were to square 14, anybody? Wait for it. Yes, it is 196. Some of you do know it off the top of your head. Well done. And then if we have -4 times 1, we get a +4. But then we multiply that by a -49. So we get plus, oops, just kidding. Way to go, Patterson. So we get a negative, there we go, 196, which means, 0. So that means that the radical goes away. The plus and minus goes away. So how many solutions? We have 1 real double root solution. And you have to put the real, to show that you understand it is a real solution, you have to put the double root. And we actually should put in there 1 real rational double root. Okay, you need all 3 of those pieces. Good, you guys. All right, so last but not least, example number 4, we have a rocket. Yes, we have a rocket that's launched from the ground with an initial velocity of 150 feet per second. Now the function given models the height. So already, remember, model is equation. Already we're given the model. And it models the height in feet of the rocket at time t. So t is our x because that's our independent variable. And it's modeling the height in feet. Okay, so will the rocket reach a height of 300 feet? Well, let's see. So that means 300 is our height, and we want to know, is this going to happen? Are there solutions, for this equation? Okay, again, we've got 2 variables with 2 variables with 2 different terms. So we need to set it equal to 0. And then, can we reduce? Because if you're trying to find the discriminant or use the quadratic formula, if you can reduce your numbers, it's going to be a lot easier for you in the end. So we can reduce everything by 2. Okay, so divide everything by 2. You don't have to, but I prefer to get it down as small as possible. So we have negative 8t squared plus 75t minus 150. Okay, numbers are still kind of big, but you know what? It's a little bit smaller, so that's good. So A is negative 8, B is 75, and C is negative 150. So our discriminant is b squared minus 4ac. No radical. And why am I using the discriminant and not just solving? Because solving is going to take us some extra steps. Here, if I can just figure out solutions exist, well, then I know that this parabola exists and that the rocket will reach a height of 300 feet. Okay, so b squared is going to be 75 squared minus 4 times a is negative 8 times negative 150. Let's see where we go. So 75 squared, and you guys can absolutely use your calculators, is 5,625. Then we get negative 4 times negative 8, which gives us a positive 32 times 150 negative. So we get minus 4,800. So if we get 5,625 and we take away 4,800, we end up with 824. Do solutions exist when our y value was equal to 300? Yes, we actually are going to have two real irrational solutions. So we say, since solutions exist, the rocket will reach a height of 300 feet. Will reach a height of 300 feet. And why am I using a complete sentence? Because this is a real life situation. If it was just find the solutions, if y equals 300, I would say, okay, well, x equals, but it's not asking that, so be careful. All right, guys, we are continuing on with skills 6 and 7. So make sure that you finish that over, well, hopefully by the end of class, but if not, make sure you finish that by the end of the weekend. All right, have a great one.